Hi everyone, welcome to the last seizure in this office. So my name is Aria, I'm the VP of Data Science here at Amperity, and today I'm going to talk to you about Clojure and data science. This is going to be a little more of an overview talk about what the ecosystem looked like, where it's lacking, I think, and probably a little focus on that because I think there's a lot of potential here, but the current state of affairs leaves a couple things wanting, and I'm going to go over things that I think are really good in the arena and share some demos of that, but then also talk a little bit about if people wanted to focus on kind of improving the Clojure data science story, what they might actually look at. And also, this is a small enough crowd that I'm actually going to just ask people to ask questions and interrupt me freely, and I'll try to respond to you. And I'll also tell you if I don't want any more questions for a few minutes. So what's this talk about? So I'm going to start off by telling you a little bit about data science and Clojure from like a slightly historical perspective. The short story is that the data science was a really early selling point of Clojure, and I'll have some data to support that. And I think something's changed in the intervening years where it's no longer quite as strong a story compared to some other ecosystems and languages. Talk about why. TLDR, the answer is Python came along, ate kind of the data science lunch, and it's taken off. And we can talk about why it's taken off and what's mixing in the ecosystem. And then lastly, I'm going to highlight some Clojure libraries and tools that I think fit well in that ecosystem. Okay, so first off, let's take a journey back to 2011. So 2011, I think either the first or the second Clojure survey that was actually done by Smeric, I think, if I'm not mistaken, back when he was kind of active in the community, there was a question about what domain are you using Clojure for? And the number one answer was web development, which is unsurprising. But the number two answer was math and data analysis at 42%, which is a staggering number, right? Remember, this is not 2019. This is 2011. This is pre-neural net, not really pre-neural nets, pre the hype around neural nets, I should say, because neural nets are from the 80s at least. This is a while ago, so that's actually significantly strong. I think having been somewhat active in the community back then and contributing to some libraries like Infer, which some of you might remember who've been doing Clojure for a long time, like I can definitely say that like if you were into data science, Clojure was kind of like the default choice for a good 2 to 3 year range. Okay, sadly this picture looks a little different now. This is the most recent Clojure survey. Math and data science is at least 2x smaller, so it's there. Some of the terminology has changed, AI, NLP, machine learning. People basically mean the same set of things. This is also a multi-select option, so it's not like that choice has been fragmented. It's actually a lot smaller. I think it's a lot smaller. And what's even crazier to think about is, A, this is a big change just in absolute terms, in terms of usage patterns. You could argue, well, Clojure's become like a mature language. It's gained a lot of adoption, so you kind of have a lot more bread and butter kind of web development usage of it. That might be true if it weren't for the fact that its data science has actually grown a ton in that time period. So if nothing else, if we had maintained the same proportion of kind of web development usage versus data science, you'd still expect to see kind of a healthy proportion, if not an absolute volume increase, because data science has grown a lot, obviously, in the last 8 years. But it's turned out that the Clojure usage has dropped. Anyone find that controversial or in any way, shape, or form? No? Okay. So yeah, I mean, it's actually kind of crazy. If you go back to 2011, this is using Google Trend data. It's hard to see here. The blue line is data science, obviously. The red line is Clojure. Clojure and data science were roughly comparable in terms of global popularity, which is a little crazy to think about. And then obviously you kind of have the progress of time. Okay, so what's actually happened? Has Clojure gotten worse for data science? No, not really. In fact, it's gotten a lot better. But what has happened is Python and kind of the innumerable libraries that surround it that I think do a lot of really good things. I'm going to talk about some of these, but before I go on, because I want this to be a little more interactive, which is code for I didn't invest as much time in these slides as I'd really like. But just to get a sense, like who uses like any of the Python data science ecosystem, which I'd include all of these tools except Python to some extent, right? If you're using any one of these, you're doing a little bit of, okay, so that's about half of you. Who's done a little bit of Clojure data science? Okay, what's what have you used?
Encounter.
There you go. That's a 2011 answer. So, yeah, no, and to be fair, it's actually pretty good. I actually think there's things it can do that you actually still have a lot of challenge to do.
Very slow.
Yeah, very slow. It's got a lot of, but not actively maintained, if I'm not mistaken. But it actually still does things that you can't do in Python. So we're going to look a little bit at this ecosystem because I think that there's, yeah, so let me give you a little preview. I'm going to go over this ecosystem. There are some Clojure equivalents. And then I want to talk a little bit about, like, do we need equivalents or should we be doing something different? Because there's the answer to, like, what's going on here is a little interesting and I think raises some interesting questions. Did you have something back there? No? Okay, I thought I saw a hand. Okay, so part of this is just the Python story, right? So part of this is just like the meteoric rise of Python in the same amount of time, right? It looks pretty similar to data science. And in actuality, I do think these two trends are related. I think that the explosion of interest in programming has been driven largely by people wanting to cash in on data science and Python just having become the default choice for that. But I think there's a little more. I think it's not just the correlation. I think it's because Python just has the best story for this. And when I say story, I want to be clear. As someone who's managed lots of teams of people who use Python for data science and tried to get into production, I can assure you the Python story is not as great as it seems. And I'll talk about where some of the holes are. But I think it is the best story for getting started. It has a really clean story there, right? These are the libraries that kind of launched 1,000 webinars and Medium posts and Lambda type schools and all those things. I think they have a really good story for getting started, and it's really straightforward, and I think some of that's actually quite good. And Clojure obviously doesn't have that, right? If I asked like all the people doing Clojure data science, what do you use? The answer is going to be kind of I write my own stuff mostly. Okay, so I'm going to talk about some aspects here. I'm going to start with, like, I think the most important piece of that ecosystem, which is, I think, the notebook, right? So Clojure notebooks Jupyter notebooks are really good for ad hoc data analysis, right? I think they're not actually the best tool, I think, but they're pretty good. They're great for rich documents. By that I mean, and I'll show you some examples because I'm going to check out of this slideshow in a minute and show some examples of what you can do. But I actually think they're bad for everything else. There's a great slide deck by Joel Gruss, who works at the Allen Institute for AI, who's you know, in full disclosure, a good friend of mine, about why Jupyter notebooks suck for a lot of the use cases people actually use them for. But I think for these first 2 points, they're actually pretty good, and Clojure needs a rich equivalent. So let me just stop and show you some examples, and we'll compare it to a Clojure thing. So let me start with, actually, let me see, did I have one more slide? Yeah, no, okay. So actually, let me just ask, who's used a Python notebook before? Just a quick show of hands. Let's show almost half of you. Okay, so like, why are they so popular? Part of it is I think that they function really well when it comes to mixing text and code and just giving a description of stuff, right? And so here's kind of like the bingo of kind of notebooks. You've got like your complicated TensorFlow, PyTorch. It uses pandas and it uses they use PyPlot here, if I'm not mistaken, maybe not. But basically, like, people write pretty sophisticated code in notebooks. They're actually running like kind of the state-of-the-art kind of Python machine learning models, training them in here. And so you can write pretty large-scale things. If I'm not mistaken, this example here, this is basically like a research paper, more or less implemented as a Python notebook. And if you think about it, that's actually pretty cool. Like, you don't have to like load up a bunch of code. You don't have to like, you know, deal with like Python requirements. You kind of just take this notebook and you can walk through it and re-execute some of it if you're lucky. And I think that's actually pretty great for learning, right? Here, I should also say this is actually really good if you need to do some amount of exploratory data analysis. And by that I mean, for context, I used to manage teams, a lot of teams that did machine learning, and most of those teams were basically 80% iteration, right? They're 80%, I have some model and I need to tinker with it a ton, make them better, and then eventually ship them to production, which was like the hard part. And most of that tinkering, this wasn't Facebook, actually happened inside of notebooks, right? So people would like have big notebooks like this that were like pretty unwieldy, and they would basically edit some earlier part if they wanted to change how they process data or change how they evaluated stuff downstream. And almost all of the iteration was actually happening in a notebook, which was great for their individual velocity of prototyping. So I actually think that part of the story is very true. Here's another example. Like, I don't mean to like blast a bunch of math. This is actually a notebook that is more or less like a lecture with some LaTeX in here. But then when you get down here, you've got some code. You've got everyone's favorite punching bag PyPlot. And I actually think these are good for learning, right? Whereas like, I actually think this BERT thing is, this is bidirectional encoding stuff. I actually think this is horrible for learning, but it's actually good for like individual kind of iteration. And I think this is actually really good for learning. Okay, so these are the two use cases I think Clojure that notebooks do really well in. So now let me jump over and show you guys Clojure notebooks. How many people have actually used Claude Jupiter before? Wow, really? Okay, but how many people here use Clojure like on a weekly basis? But no Clojure notebook. But you know what's interesting there is you use Clojure and you use Python notebooks, but you use Clojure and not Clojure notebooks. Why is that? Huh?
You have the REPL, right?
Yeah, we'll come back to that. I think there's some like, so I would go back. Let's talk about that. Where'd my window go? So you couldn't. I don't think I would argue you can't do this in the REPL. This is pretty hard. This is like you wouldn't do this at the REPL.
No, but the REPL with your editor works much better than this.
Yeah. That's one question. I think what's the challenge with that though?
You can't have the visualizations.
You can't share it with people.
Oh,
Yeah, you can't share that. That's the key. I think that's one of the key reasons. But remember, if you can't share it with people, it means you can't get other people to learn how to do it, which means you can't build a community. So I think that's like one of the trade-offs, even though I think the tooling, you're right, is arguably at least as good. Yeah.
This might be rather dated, but I spent a fair bit of time with Gorilla REPL, which has some overlap with IPython notebooks and stuff like that. Have you used that before?
Yeah, I'll talk about Gorilla REPL. Yeah.
Okay. I've never used Clojure or whatever.
Yeah, so in fairness, this talk is largely biased towards the things that I've contributed to. So like I wrote some of Claude Jupiter. So I'll talk a little bit about Claude Jupiter, and I'll show you that like it can do some stuff. You can kind of use it. I've actually written ML in it before. I'll show some examples of that later. But it's not by any means as smooth an experience. So this is Claude Jupiter. I actually have some examples just to like kind of compare and contrast a little bit. Let me actually, where is my home? There we are. Okay, so like here's like a simple example of Claude Jupiter. So you can run stuff. You can write like HTML that gets rendered as hiccup in case you want to do that. It also supports Markdown if I'm not mistaken. You can add dynamic Clojure dependencies via Pomegranate, if anyone's used that before. So even if you don't have it installed in your local kind of M2 repository, you can just call up a magic thing and it just appears out of nowhere, which is actually nice if you compare that. Like obviously that's actually better in some ways than Python notebooks where you have to actually have pip installed it or whatever. And the niceness more or less ends there. So I'm going to show you guys, if I can get this to work, I'm going to show you like a visualization demo. And since most of you have used Python notebooks before, you'll know what you can do with PyPlot. So I actually think I deleted this library, but I'm actually for the first time, it's fetching from the internet like Oz, which is like a Vega wrapper. And hopefully, yep, there we go. And then I'm going to execute that. And then you're going to get like a nice little chart here, right? And so under the hood, this is using Vega and Oz. Who's heard of that or any of those tools before? So Vega is actually if I'm not mistaken, a JavaScript visualization library. I think it's actually a pretty darn good choice for like if you ask me like what would I use to make something now, it's probably Vega. Oz is a nice Clojure wrapper around it that gives you this nice declarative kind of data that you just pass into the visualization. And so this actually works in Claude Jupiter now. You could do this now. Again, I'd be hard pressed like you can't do this at the REPL nor with Cider or whatever, right? This wouldn't be feasible. And I think it's really valuable if you're mostly doing data analysis. Yeah.
When you were asked before about what people use as opposed to Jupyter notebooks, my answer would be org mode. in Emacs, which
Super beginner friendly. Yeah.
that's it.
No, it's pretty valuable. I mean, Fetterman's a big org mode fan, if I'm not mistaken, right? Yeah. No, I actually love org mode too, and to some extent, like what I'm really talking about is, I think like there's a chicken and egg problem with these kind of communities where, like, if you don't make your stuff beginner friendly enough, even if your community has really awesome tools, you don't end up with kind of, the rich developed things like your PyTorches and your TensorFlows, and that's sort of what this is getting at, I think.
Yeah, I'm not selling it, I'm just saying it does do things you're talking.
Yeah. So where were we? Yeah, and so this obviously, like, you can run this and get pretty fancy graphics. I would actually contend that from a pure charting point of view, Oz is actually competitive with PyPlot, I think. It doesn't have all the features, but you can actually do fancier things. Like if you've ever tried to actually just save an individual picture in PyPlot, good luck. It's a little challenging. So I actually think this is a pretty good overall like story. Of course, if you use Claude Jupiter, and so having been one of the people who's worked on it, it's nowhere near as rich or good as like the Python one, but it could be. I think it's basically has like 2 or 3 people who contribute to it, and like I haven't done it in like a couple months. But I think like if you wanted something to contribute to that, I think has like a good amount of payoff to effort, I think Claude Jupiter is a good choice. Gorilla REPL is interesting. I think unfortunately more or less like IPNYB as a file format is WAN, and so I don't think there's room to innovate there because I think like notebook format is basically WAN out, and it's more or less just about having like a first class experience. In my personal opinion, that's what I think at least. Okay, so let's jump back to the slide. So that's Python. That's notebooks. So if I had to give Clojure a grade, it'd probably be like a B- C+, right? There's something there. It's okay. It has some cool functionality, but it's nowhere near as strong or as easy to use. You have to install your own kernel and all this other crap. Pandas. So just show of hands. Who's used pandas before? Okay. Put your hands down. Like who's used notebooks without pandas before? Yeah, basic notebooks without Panda at all. Almost no one, right? So there's a reason for that, right? Like they kind of go hand in hand in data expenditure. So I don't have to tell people what pandas are because it seems like most of you have used Panda before. But Panda is basically like a data frame library. More or less, it takes like the internals of like a relational data, like how most relational databases are implemented now, and it makes them available kind of in effectively as an embedded library, and you can do database-like things with it, but without any of the performance. So it's true, but it has some nice like interactive capabilities. Like when I'm kind of joking, but it's actually true. Like data frames basically do what, like, if you've ever looked at the implementation of MySQL or whatever, they're very similar. They're just not as performant or designed to work as well. They don't have like query planners, for example, if you like issue a series of queries to them. So the nice thing about pandas, though, and the reason why people use them, and maybe you can tell me for those who've used them what if you have a different answer than this, but the real reason you use them is because they're super well integrated with everything, right? Like Panda data frames work really well with scikit, right? You can, if you've ever used scikit before and built like a simple ML model, you can just pass in series and data frames to that. They work really well with PyPlot. They have a lot of pretty printing and things like that. And then the question is, right, so, sorry, that's actually just a Jupyter notebook. Whoops. Okay, so let me actually jump here and show you guys like a quick example of the closest Clojure equivalent that I think we have. So here's like a simple Panda example, and the goal here is, like, you've all seen this before. I just want to show you like the kind of thing you would do, and then show you like more or less a Clojure equivalent, and then have you guys like take a look at some of the differences. So here's pandas. Seems like most people are familiar with this. This is like a simple CSV that just has like movie sentiment reviews and tweets. So the rightmost column is sentiment text, and this column is like the sentiment of like whether or not the person liked the movie. And so, this cell right here is basically just tokenizing It's just tokenizing one of the columns so that you could pass it into, say, like a logistic regression model or something, some kind of bag of words style model. And then this is just executing what's the average length in words of each of those kind of tweets, and the answer is around like 12.9. Okay, so no surprises there. That's kind of a relatively simple example. It's worth noting like how nice like it is to be able to like visualize this data. So, you know, I would contend that like if you compare this to a pure REPL experience, right? Like yes, you can pretty print stuff. I would argue it's a little easier to kind of see what's going on with all the extra visualization aspects that you get out of notebooks than with the pure REPL itself. I don't know if people would disagree with that or not, but that's kind of some of the value here. So do I have a slide for this? Yeah, so then the question is, what's the Clojure story for pandas? And the answer is, there's not really one. Has anyone ever used a Clojure data frame library that kind of does similar things as pandas? Yeah, and it's not just a notebook thing, because how many people have used pandas outside of a notebook? Yeah, most of you probably, or like most of you seem to use Python on a regular basis. You use pandas in normal Python code. It's not just a notebook thing. And we actually don't really have an equivalent in Clojure that's kind of taken off. There's a couple smaller libraries. I'm biased, so I'm just going to tell you about the one I wrote. I don't necessarily even think it's the best one, but I think it's the best one I could find. So Koala at a high level, and I've got the GitHub link there. Koala is basically a data frame clone that does a small subset of it, but looking for contributors. So if you want to help out, and the Clojure kind of take on data frames is basically data frames have a sequential view, which is into each row of a data frame, where each element is kind of a map from the column to the key. And then when you think about them associatively, you think about them associatively as columns, right? So I'm going to jump to a quick demo and show you almost the equivalent thing working. So here's Koala. I'll just show you this really quickly. So data frames can be treated as a sequence of rows. Let me pump that up a little bit. So if you can read a data frame from a CSV, and you can treat some columns as numeric. If you treat it like a sequential thing, then you basically get sequences of key value tuples, right? Like so, it's effectively like a map, and you can filter and do all those things too. But then the weird thing, and this is actually something that I'm sure Rich would be very unhappy about, is that it kind of changes behavior if you think about it associatively. So if you think about it associatively and you try to associate something onto it, associating is like adding a column, right? So this is a weird kind of data structure, but it's actually I think if you've used data frames before, this is actually how they operate, right? You can iterate when you iterate over them. You usually iterate like row wise, but when you access them as maps, you access columns, right? So it seemed like the closest like Clojure parallel to some of that. So let me show you a Koala demo that hopefully won't break, because I had to make a small edit to make this happen.
I have a quick question.
Yeah.
So what is kind of your motivation to move to data science Clojure script, Clojure as opposed to Python? Is it like speed, syntax flexibility? What
Yeah.
are some of the things you're looking for?
There's two answers to that question, I think. I think one of them is just purely that there's a bunch of things I like about Clojure that have nothing to do with data science. And that like the kinds of things I see people doing with data science, I'd like them to be able to do them in Clojure, right? Because I like a bunch of other things happen to like a bunch of other things about Clojure that I think, to be honest, are more important than the availability of a single library or something like that. So that's one motivation. I think the other is frankly just like community building and giving people tools that they already recognize how to use if they're thinking of transitioning. But like I think to answer the deeper question, it's like, why just copy all these tools? I think there's other answers as well, and I'll talk about some of those a little later. Okay, so here you go. So Claude Jupiter, again, not as much of a first-class citizen as Python notebooks. So you have to like be aware of the internal functions to use here. So this top is basically, it's requiring my Koala stuff and a couple namespaces there, and then it's it's also going to use some Claude Jupiter helpers in order to render stuff pretty. Because again, not a first-class citizen, so when I render kind of HTML hiccup, it doesn't like natively know how to do that. I have to like make it do that. So I'm going to load it, and then I'm going to do this, which is going to actually make a table that's not quite as pretty, but not so bad, right, in terms of like looking like a decent kind of thing. But notice what I had to do to get there, right? Like I had to like call a bunch of magic functions, right? So if you recall in Python land, you just had to say, give me the first 10. So this is effectively saying, take the data frame, give me the first 10 rows of that data frame. And then when you just evaluated that, the notebook was smart enough to render it as a table. I have to basically say, go to HTML and then Claude Jupiter helper, please like make this into hiccup or whatever. Take this data structure and make it into hiccup. So it's not quite as well supported. And then let's look at like a simple transformation example. So again, this is the identical version of what was there before. I'm going to take a column. I'm going to add a new column, which takes another column and basically tokenizes that. And that's going to do exactly what you expect. It's going to add a tokenized column that's going to have a sequence of words basically from the tweets, just as before. So that's okay, right? That's like a B-ish job. It's like a little more complicated and requires a little more internal knowledge of how things work, but it's okay. So that's about where things end in terms of the okay part, because what I'm going to do down here is there's this large.csv is about 200 megs of these sentiment analyzed tweets. And I'll run it right here. It'll probably be done by the time I finish this sentence. Yeah. And then what do you guys think is going to happen on the koala side? You don't have to wait that long because you will exhaust. It'll finish quickly, but not in the way that you're hoping. It'll run out of memory is what will happen. And I mean, so to be fair, it'll take a while to run out of memory. But I actually tried to make this performant. Like Pandas under the hood uses some C++, and it doesn't actually load everything, and it looks at the side. It does a bunch of smart things that I'm not doing. But this is not unperformant code generally. This is like pretty performant, but like the amount of time it takes to make large CSV works are actually quite time consuming. And so none of that's actually happening. So I'm going to give that like a C-, I think, in terms of like functionality, because, yeah.
So I'm just curious, what is the internal representation that you use for the koala data frame? Is it just a Clojure data structure?
Not quite. So it matches what Panda is actually doing when it loads, for the subsequence it loads into memory. The problem is that Pandas is smart about how much to load into memory, and it does a lot of like, so it uses the file into OS cache, so it has a bunch of like low-level stuff to make that work. But the in-memory representation is that, like a lot of databases, is you're storing each column separately, and each column is stored as primitive array types for like numbers and things like that. And for something like an object, it's usually just like it's like seeks and offsets of bytes basically. So it's doing more than you would think in terms of performance, because even getting like small CSVs to load and add columns like is a little challenging. If you need to manipulate columns, you have to store things as columns basically. The same like databases, right? Like typically store columns separately. Does that answer your question?
Yeah, and follow up to that. In Clojure, there's a tendency to represent everything as a map internally or as some native Clojure data structure, whereas in Python, generally you would represent things as your own custom class.
Yeah, so I'm doing the latter. I'll actually just show you. I'll just bust this open.
Is it more difficult to integrate with Claude Jupiter since things tend to be just plain old Clojure data structures?
Let me answer. So let me take the first part first and the second part second. So the first part is like, no, this is like all custom collection behavior. So this is one of the few times I actually wrote a def type that does like it's not actually just deferring to some underlying Clojure structure. It's actually like pretending, it's pretending like it's a Clojure type, but under the hood, it's like fundamentally a mutable thing. Or not mutable. It's not actually like a Clojure thing you're talking to. You're talking to something that's like pretending like it's a Clojure collection. But to answer your second question, which was around, remind me what the second part was?
Does it make it harder to integrate with Clojure Jupiter if your data structures are native?
Oh no, yeah. So the reason, yeah, no, not at all, because under the hood, Claude Jupiter just uses, like, when you send something, we'll just use print string, and so as long as you implemented like print method, it'd be fine. The problem is actually this. The problem is that Jupyter notebooks are so tightly integrated with the Python ecosystem that there's a part of the Python code that's called like magic, if you've ever looked under the hood. And what it will do is, because it's printing out a data frame, the notebook will print out an HTML version basically. Right. So and whereas in Claude Jupyter doesn't know that. Claude Jupyter doesn't have like hard baked in, like, because there's no winner, there's no pandas in the Clojure world. It doesn't. There's no way to do that. You could obviously use like tagged literals. So like one of the things that I added that hasn't gone through a PR yet is just like use tagged things. So like say, yeah, exactly. But like again, this is like a sophistication of the ecosystem. But on the Python side, the way this works is it's just hard coded that anything that's called a data frame renders like this when you call it. Yeah.
You have like interfaces that you just implement for the data structure, like this like print two-string function or something like that.
Yeah. So you could. You could certainly, like I said, you could override like the print method, the def method for print or whatever, and get that to work. It's a little more complicated because it's not just a string; it's a string plus like a meta type. So like making it generate the string of the HTML will be easy, but you also have to tell Claude Jupyter this is HTML rendered as HTML, because it also renders like ping directly or images. So like I think the solution is tagged literals and having those literals like describe how they work. But I think like the bigger point is that like if there was already a pandas winner, it would kind of already do this. And the reason it's not is because there's like not a standardized ecosystem. Yeah.
I'm kind of curious. It seems like half the time you're thinking about this as an associative thing,
Yeah.
and half the time you're also thinking about it as a sequence. And like typically, if you're dealing with maps and filters, your entity, your sequence would be the last parameter. When you're doing stuff associative,
It'd be the first one.
The first one. Are you like running into a lot of problems where you're modally switching between those two with the same data structure?
Not really, because I think there. Like if you've played enough with pandas, I don't think people think about it like this, but when you're manipulating columns, you're either manipulating columns a lot, or you're actually looping for all the rows. And you're rarely trying to mix both of those things together. So like a filter case is I need to like reduce the size of my data frame somehow. And the associative case is I'm defining a new feature a new column in terms of other columns typically. And like my experience with that is usually like I'm gonna define some new feature that I'm gonna pass downstream into ML. And so like I'm gonna do that. So I don't find that actually happens a lot. I do agree that the way that data frames are used is a little confusing, but they're maximized for convenience rather than coherency, which is not, which is something like Clojure people kind of like balk at a little bit. I think it just like goes against the grain of the community and the way that people think, I think. But it's maximizing, like it makes it's more important in pandas to make it easy to do something than it is to have like a coherent philosophy of what the hell you're dealing with. Okay. So so let's talk about ML. So we've talked about notebooks, we've talked about pandas, and now we'll talk about ML. The Python story for ML, of course, is like embarrassingly rich, right? Like there's scikit, which I think is probably the most used thing still. For simple models like random forests and like logistic linear regression and nearest neighbors and all those things. And it has a really good integration with PyPlot and data frames, right? So in fact, most of the way that I think scikit gets used in practice is like via data frames. And I believe most of its usage is probably in notebooks, is my hunch, especially, well, for a reason we'll get to in a few moments. So your kind of basic machine learning story is really strong, I would say, in Python here. Neural nets, there's obviously PyTorch and TensorFlow. I personally am a big fan of PyTorch, so much so that I wrote like a library that more or less cloned it in Clojure with some changes. I like both of these libraries. I think they're both really good. I think that both of these setups work well in notebooks. It's super easy to have like one place where you can use all these things at once. They all work really well together, and the story is really good. From a learning perspective, I have almost no complaints about this. Okay, and just a quick show. Who's kind of used PyTorch, TensorFlow, Scikit? Okay, not so much. So okay, less on the. So I don't want to dwell on the ML stuff since it seems like it's less used. But because in reality, I think most of the time that people spend doing data analysis is usually going to be in pandas more so than it is going to be in like ML stuff. So it's not worth dwelling on too much. But the Clojure story is a lot less good. I think that there's not really a Scikit equivalent. I think Incantor was probably the closest thing. I think so. I wrote a neural net library, and I actually gave a talk here about a year ago on it called Flare. I actually really like it. I like it better than PyTorch in terms of like ergonomics, but it doesn't have anywhere near the same level of like things operating within it. And the GPU story is a nightmare, which is something we'll talk about. And that, in part, that's due to like how Java and some of the Java GPU stuff. But the best neural net story, I think, in Clojure is probably MXNet. I'll have some examples of this in a few moments. But so MXNet is not actually a Clojure native thing, right? MXNet is I think it's actually under the hood written in C++, but it has bindings to every language possible. It's mostly supported by Amazon. It's basically like its own thing that's kind of third or fourth fiddle to like PyTorch and TensorFlow and all those things. And it has like an actually pretty good Clojure wrapper that's pretty well supported. The unfortunate part is you're on top of MXNet, so take that for what you will. I've got something that I've been trying to get people to contribute to, but I haven't had a lot of success called Flare that I'll show you guys again. I don't think any of them are there, but there's actually one thing that's actually true about them, at least for Flare, and this is one of the advantages. Like having supported teams that like do stuff in a lot of ML and Python for a long time, the story of productionizing these things is horrible. Like if you've ever done ML consulting, sometimes I used to call it like how to teach people to not use Python or people who try to use Python in production and fail miserably, and then they have to find some way to get their ML to execute in either the JVM or .NET or C++ or whatever it happens to be. And so I've spent a lot of time seeing, yeah.
I'm not really familiar with this. Can you just briefly explain why that is? So typically what happens is this, right? Someone will like build a model, like build a PyTorch or a TensorFlow model in Python, they'll save it, and then it's time to actually go and execute that model in production against something. And typically what they'll notice is that making a high performance, and again, like I'm using experience from like places that have like a lot of scale. So if you're dealing with small traffic, it maybe doesn't matter too much. But basically, like you make a model in PyTorch and now you want to use it in production, right? Unless your services are written in Python, like how do you execute it, right? And there's a couple answers to that question. There's something called Onyx that you guys might have heard of. I don't think it's ready for prime time. I mean, I can tell you the horror stories about. I can tell you what happened at Facebook with this kind of stuff. Basically, people had to rewrite models in C++. But I'm sorry, was it just that the models end up executing too slowly at scale? Because
Yeah.
It seems like if the problem is just invoking a Python binary, you can just do that.
Yeah, the problem is that, so the problem is twofold. The problem is one, that like even though you can do a lot of data science in Python, unless your backend services are written in Python, you end up wrapping a microservice around just the Python model. But then the model itself, like PyTorch, for example, is not actually recommended for production use. Just to give you, like, it's not in use, for example, at Facebook in production. By far, it's like way too. even like TensorFlow is probably too slow for most like high usage cases. And so for a lot of the big ML things, they end up getting custom code written for them. And so I think these are great prototyping tools. So like what I've seen teams do is teams will like iterate in PyTorch, TensorFlow. They'll find out what works offline, and then they'll have to like go productionize that.
And so, and this is not just about Python, although it's a little like, all of the problems that Python has as a language in terms of fast execution, like overhead of object calls and all those things, translate into the actual ML itself, right? So even though under the hood, your array multiplication is using like C++ BLAST or whatever, or GPU code or whatever, the actual graph algorithms that are doing the automatic differentiation are written in Python, right? So the code that like, and actually we can just like, let's see if I can, I don't know if I actually have the example here, but so yeah, actually maybe this is good. So this is BERT. Let me actually find the ML part here.
So maybe they might try to move it to Spark or something like that to make it more.
Well, I mean, then PyTorch doesn't speak Spark because like the things that bind operations they're all written in C++ under the hood. Like some of them are written in C++, some of them aren't. This isn't super amenable to Spark, in part because the operations don't distribute like in an RDD style way. This is usually like so like this code is basically. So this code basically is mostly going to create a graph under the hood between all the variables here, right? So there's effectively like an AST that is generated in Python code for all these different variables. And then when you execute this model, something is doing math operations between the nodes of that AST. And that's basically how like the automatic differentiation works. And that code's written in Python, and it's subject to all the normal problems that Python has with the performance. And they actually grow to be a good chunk of the running time. In fact, like if you do any kind of like structured ML, you spend more time in kind of like object hell than you do in like BLAS. And that's only a recent thing because of the depth of neural networks. Like back when it was like, just like logistic regression, you wouldn't have that because you didn't have as much structure. But now like the Python code is basically encoding a lot of complex operations that are all like, executing it. And so like what people have done is like Microsoft has this thing called Onyx. And what Onyx is supposed to do is try to take these static graphs and translate them to C++ automatically. It's not ready for prime time, at least, and like we actually personally tried that in a couple different ways. It doesn't quite work yet. I don't think it's ready yet. It might be in a few years. It might be in a few years you can write your code in Python and then something will magically translate it to something performant. I don't think we're there yet, and I don't think we will be for a while. Whereas, let me see here. So here's Flare. So Flare is the library that I wrote. So Flare actually, I don't have an example, but Flare actually executes inside of a notebook, just because it's normal Clojure code. And the version that executes inside that notebook is the same version you can put in a production server and have it be quite fast. So I think from my speed tests that are in a blog post on my website, I got, like, without trying too much, 3 times faster. And that's not like my brilliance at writing this kind of code. It's mostly just because like it's the JVM and has a 15 nanosecond overhead for function calls as opposed to Python, right? It's mostly just like the raw primitives of the language and the performance of the underlying VM and everything, as opposed to anything else. Because to be honest, most of the code is pretty darn similar. So that's actually a huge advantage, right? The fact that there's no barrier between the thing that you could easily, not easily, but you could prototype with and then take that same thing to production is pretty powerful, and like, I think is actually a great story. But I think the reality is data science is in a point where there are more people interested in learning it than people actually using it. And so I think that's partially why that discrepancy exists and why Python plays such a big role, is because like that lesson that it's really hard to get to production is not quite something that's been fully internalized yet. Oh, let me show you MXNet too, because to be 100% honest, I think the pragmatic thing for myself to do, as someone who cares about this, is actually not write Flare anymore, and instead work on MXNet. And I actually know the person who wrote it, and she's asked, she's like been interested in contributions, and there's some of Flare that like has influenced the shape of how this thing's. But this is actually if I show you some code, it looks roughly similar to Flare in terms of how it maps to Clojure. Let me try to find an example. Where to go? Yeah, so here's one. So basically, if you look at this, so I actually tried to highlight both of these, but if you look at the LSTM code, that's kind of in Flare and this, they're broadly similar. There's a little more ceremony in the Flare because of how it has to talk to the underlying C++ code that actually is doing MXNet.
But it's usable. It's a little more verbose than I'd like, but I actually think it's, in terms of functionality, it's on par with PyTorch and TensorFlow and everything. It's just a little more challenging to use. So I actually think that to be 100% honest, I think if you're interested in this space, the right thing to do is go work on MXNet and make it like more of a first-class citizen. Okay. Cool. So I'm going to only take about another 5-10 minutes or so. But so let's talk a little bit in backup, because a lot of this talk has been, what's the ecosystem people currently use for data science? What do the equivalents look like in Clojure? And like some of them are there, but they're not like quite there yet. And there's reasons to be like that I think you can do stuff in it, but it's a little more challenging. I think the big question is like, what do you actually want to do here? And I think there's like two basic strategies. I think one of them is to say, and I think this is actually important, is you should attract existing Python data science folks and match their current experience. I actually think this is pretty important, because I do think like one of the ways Clojure gets users are people who use other languages and kind of get fed up with them, right? I think like that's a pretty common pattern, right? And I think to some extent, making that transition easy means having tools that kind of roughly perform the same role. They don't have to be identical, but they have to play the same role in the ecosystem with like comparable ballpark functionality. And so I do think it's important to do some of this like matching. But then I think there's this other question about like, what's the unique value proposition? And I'll talk about each of these. So on the first point, I think what I think is kind of going to be pretty obvious is like, there needs to be better existing libraries that work well together. I think that work well together part is important because it's not traditionally a strength of list-based languages. But I do think like picking a couple winners, even if it means like, I don't get to work on Flare anymore and I work on this other thing, is probably like a good thing. But I do think putting some like open source effort on some of these is really awesome. But I do think like in that story, like I said, I think there's like a clear winner on the notebook side in terms of something which is close. The Claude Jupiter is like, it's a plugin, it works in there, it does a lot of things. I think with a little tender love and care, it could be pretty usable. Same with MXNet. I think MXNet with a little TLC could be like comparable to like some of the Python tools. But I think like pandas, for example, is like a shit show, right? There's nothing that's like playing. And I think, ironically, that's the most important part of the ecosystem. And there's kind of not really a Clojure story there. And I think that's really important for a lot of the ad hoc data analysis. I see people, like to be honest, like 80% of data science is like data analysis. And pandas is really good at that. And that we don't really have in Clojure, despite having some good primitives in the REPL and things like that. Okay, let me answer this other question though, which is like, what's the unique value proposition? So like I often tell people, sometimes when you look at languages or ideas, there's what I would call deep value, which is like the real reason people use Clojure is not because of any fancy library or anything like that. It's really because like the fundamentals of the language are good, the philosophy of the language is good. It does a lot of like, it gets out of your way. Like there's a lot of reasons we use Clojure that are hard to distill compared to like Rails, right? If you say, why are you using Rails or Ruby, it's going to be Rails, right? So that's like, I would say there's like shallow value and deep value. And I think Clojure has a lot of deep value, but that's actually kind of not great for its story in terms of gathering like a larger community of users around it. You need like immediate value, immediate kind of quick value. And I would say like the closest thing that Clojure used to have to that is the REPL, right? I think like a couple years back, you show someone the REPL and their mind was blown, right? And now I think like people have seen enough things that are like it, like notebooks and, like Java's getting a fucking REPL, right? Like that it's a little less of like a distinct value proposition. I would actually argue today, if you said, what is the coolest thing that you could show someone in Clojure in 5 minutes and have them get why it's valuable, it's actually Figwheel, right? I think bar none, Figwheel plus Reagent is the best web development experience in existence, I think.
Can you show us?
Oh, I can't. How many people have seen Figwheel before? Okay, just for your benefit then. So, which is fine. I actually think Figwheel is, I think, the bar none.
The 5-year-old Flappy Bird video.
I was just going to jump.
For 5 years, and it's like, where's
Yeah, it's hard to. So, what Figwheel, is this demo linked in here at all?
might be on the live coding.
Here we go. So I'm going to turn my sound's off, right? So basically what it is like, it's basically live reloading your JavaScript and
that's basically it. So you can you edit code, it magically changes. Reagent, which is the Clojure kind of one of the Clojure React wrappers, is probably the best version of React, I think. React, I think, is probably the best way to build like web apps, in my personal opinion. I thought that before I worked at Facebook. I think like if you show people Figwheel, in 5 minutes they'll get value. They understand the value. It's like super transparent. And so when I think about languages and value, and I think the same thing is actually true of notebooks and pandas. Like I think if you show someone who's like maybe coded a little bit like a Python notebook with pandas, they get it. Right, and I don't think Clojure really has that, and I think in particular it doesn't have that for data science, which is like part of what I think about. And I think that like I do actually think that there is room for something that is like a REPL and more visually interactive, but not a notebook. And I don't think that exists quite yet. Like something that's like easy to use and has like like with the BREPL stuff, I think is like possibly pointing towards that. But I actually think there's room for innovation here. I just don't know quite what the right answer is. If you guys have used notebooks a lot, what you actually find is the fact that you have to jump backwards to do stuff is actually really annoying. And I actually wonder if there's like a reactive version of something where you basically change something in how you're processing data and you see a result. And I think there is actually room for innovation that Clojure would be a good fit for. I just don't know what it is. And I think the other thing that we can really rock at is the productionization story. Because I think again, because there's a lot of hysteria around ML, more so than there is productionization, people don't see that. But I do actually think it's really amazing as someone who's done a lot of ML in production that you can have the thing running in your notebook go into production with like high performance and be good. And that's really valuable.
At some point, could you say something about Spark?
What do you want me to say about it?
Well, isn't it relevant to data science and Clojure? And why, if not, why not? And RDDs are probably similar to data frames, right? Except that they may not be in memory.
Yeah, the reason why they're not relevant is because most ML is trivially distributable. You don't actually need most of what Spark does. Like I actually think Spark has a good ML library, but it doesn't actually need one because almost all ML.
Specifically focused on ML.
Yeah, because I'm thinking about data science and ML. Like if you ask me like what is my big data analytics, like my big data kind of like what is my distributed system kind of relational database story? Yeah, Spark plays a big role in that, I think. If you ask me like how do I build the database of the future that kind of is in memory and really fast and I can have like ad hoc query analysis on, that's not like when I think about data science, it's much more about individuals, prototyping, and it might be large data, but it's not in the context of a distributed system.
You could train your data on a small data set, basically.
No, I mean like Python notebooks work on, you can load gigs into them, right?
No, but you're not going to train on 10 terabytes usually. So.
No, you're not going to train on 10 terabytes. But to be fair, like if you've actually trained large like models, you're using GPUs. Show me how to use Spark and GPUs together, and I'll pay you a lot of money. It's not quite happening. But I think Spark is awesome. It's just not relevant to the specifics here.
That's kind of go back to the question I had on what you've seen in getting things to production, how much the hardware infrastructure played a role.
Yeah.
It's like I can give you a giant box of GPUs and do a lot of
Well, interestingly enough, I think one of the things people don't get is GPUs are really valuable for training models. They're not really used for model inference, right? So like for a bunch of reasons. One of them is that they typically like to give you like an example, let's say I write something that does like I take an image and I like do some object recognition, right? So typically like someone uploads an image and I want to give them a result right away. And GPUs are really good at batching a bunch of things, right? So typically the way GPUs get used in ML is you take a bunch of examples, you kind of stack them as matrices, and then you execute them all at once, right? But if you're running a service where someone gives you something and you're expected to give them an output quickly and you're concerned about service latency, you're not waiting for like 3,000 examples to show up to shove onto like a 128 gig Tesla GPU, right? That's one. The other is that if you do the cost-benefit analysis of CPU versus GPU, GPUs are certainly faster, but if you're talking about like serving, if you've got like even 100 machines, it's much cheaper to just use CPUs than it is to try to like buy GPUs, because GPUs are expensive artificially so because of arguably Bitcoin. Yeah, so yeah, I mean, unless you're Google, right? So Google's solution to this, yeah, exactly, is TPU, is like TensorFlow, like the TPU units, which I think are interesting, and I think like what like custom circuits or whatever. I think were probably the future where ML inference goes, huh?
Are they ASICs?
No, it's what's the phrase I'm looking for? Where you have like software that reorients the circuit board.
FPGA?
Yeah, that. So I think it's more likely you have a future where like neural nets execute on something like that than you do everyone buying GPUs for production commodity servers. Like I don't think Google's going to go out and be like every machine that serves search queries that does search ranking is going to like have a GPU. That's actually not like an affordable solution. It's probably going to be more like what they do with TPU units.
It
That's the
depends.
Microsoft model in terms of the programmable arrays.
Yeah, I mean, I don't think you're gonna. I think GPUs will get used for training. I think for inference time, people will end up using like more custom like computation units.
And I think that's a good place for Clojure to debate, but Python's already there. There's a great Python framework called MyHDL, which lets you write high-level Python and test it as well as high-level using whatever library you want. At the end of the day, though, it compiles a subset of that to Verilog, VHDL, that you then send to an FPGA.
Yeah, I mean, I don't know about that. I've used a lot of things that translate Python into like executable C++ like operations, and they're not as flexible. Like if you're doing something trivial, where frankly you wouldn't have even been using like PyTorch to begin with, it works really well. If you're doing something complex, like you've got a tree structure or whatever, it doesn't necessarily compile down to something cleanly. I think things will get there, but I think it'll take a couple years before there are things people use.
I think the situation with GPUs is problematic because the data set size partly, that many data sets don't fit in 4 gigs, 8 gigs, 12 gigs. If 3D X-point terabyte modules start being put, or Optanes start being put on GPU cards, that could change in a couple of years or less.
So this kind of initial preference that Clojure had for data science, was that due to the fact that this was kind of language of choice for artificial intelligence or anything like that? Or?
I actually don't know. I think it was a couple of things. I think it's that one I think is that like Python didn't have there wasn't another ecosystem, and like prior to like 2010, Java probably had the best ML tools. It was probably the friendliest programming language to use that had them. Like C, meaning like people are more likely to have learned Java than C++ back in the like late 2000 early aughts or late aughts, early 2010s.
Was the Stanford library then?
Yeah, there's a Stanford library, right? The Stanford NLP and things like it, like Weka. There's a whole bunch, and then Clojure basically provided a cleaner interface on top of a lot of the stuff. And I think a lot of stuff flew out of that. There's a couple of early startups too that I think played a role. I think like like Flightcaster and a couple other things. And what's the one in LA, the Gil Alves company? I don't remember, Premise Data or something like that. I can't remember. It was one of these early ML startups that like used Clojure. I think there's just a couple like anecdotes that like I think built a community around them that were pretty good. And remember at the time there wasn't a better story anywhere else, right? So if you wanted to write machine learning code and didn't have a programming background, I actually think Java and Clojure are probably actually the best bets, whereas that's not true any longer. Any other questions?
Yeah, the comment. Super interesting, lots of food for thought. I think there's competition to Clojure that's not Python out there that probably took a lot of mind share away from Clojure in terms of these things, and that would be Julia. And Julia it's basically an infix list by way of Dylan, if you're familiar with that language family. It has, macros, the way you recognize them in the list, because you can take that infix. Abstract syntax tree is available to you, so you can write macros, no problem, do manipulations. Performance, it runs on LLVM, so if you use it correctly, it's native. And pandas, there is a data frame clone on it that I believe is pretty close to the Python one. There's Jupyter Notebook integration.
Yep.
There is, I don't know what the ML story is, but I do know that, for example, supposedly the numerical differential equations library is supposed to be one of the best in the world.
Yeah.
The story with linear algebra is it uses MATLAB syntax, so if you do linear algebra, it's just do it.
I think so I think like Julia is probably the opposite of Clojure in the sense that it's got the ecosystem, but like does it really have a lot of users?
Yeah.
I think it's a good. I actually like it as a language. I think it's got a lot to offer, but it just doesn't seem to have mind share. It has the same problem, a similar problem to Clojure, that like it's a vastly better language than Python. But I mean, in my opinion, I guess.
it'll take the academic market as well. Like Python did that too. Like a lot of academics use Python instead of MATLAB, instead of
The academic market, and there are dozens and dozens of dollars.
The notebook system, they have
Yeah.
probably the first one.
Yeah, I actually quite like Julia. I mean, I do like Julia, but I don't think it really competes for the broad mind share amongst programmers, I think is my claim, yeah.
Maybe they just need to make a web development platform for it.
They need to make a Rails for it, yeah.
Like a web development platform, like R doesn't have the mindset because it isn't really a web platform, so.
Yeah.
That's a huge one, so.
Well, I mean,
Amongst statisticians, yeah.
Yeah. Between the 2 points on your previous slide of can we have comparable tools and what's our unique value prop, right?
Mhm.
Does it seem like it's worth inverting those? Meaning, one of the points you said is that there's a lot more people who are interested in machine learning than people who are actually doing it in production.
Mhm.
And the thought process I have is like, who's the better target audience? The people who are using it in production and actually went through that whole process of like try and run their models in Python in production
Mhm.
and failed miserably and see a Clojure equivalent that's easy to run in production versus all the people who aren't actually ever going to use it in the real world that need a friendly entry point.
Yeah, it's a good question. I don't have a great answer. I think like to me what I do is I look and say in terms of value, because like my mind is like what's gonna make the community like to some extent larger. Not that large is the most important thing, but I do think it's important. I do think it's something that like not enough people in Clojure think about because they're like our language is awesome and like who cares if we don't have flashy things. But I do actually think it's important. I think the answer is the proof here is like yeah, people might come into Python initially with this data science thing, but like the amount of usage it sees outside of that as a result of the fact that's how they found it is really big, and I think in and of itself valuable. In terms of what's more important, it's hard to say in the absence of a specific hypothesis around the second point. Like I personally think that there's room for a REPL with better graphics and like that is a richer like media like I don't want to say media experience. Like I think a REPL designed around data analysis would be really interesting. I don't think we have it, but I think it'd be really awesome and it's something somebody should work on. And maybe if that existed, I'd feel differently. But as it stands, I think the sanest thing to do is, because there's enough people out there working in Clojure and in the data science channel on Slack for Clojure and everything. I think there's enough room for both, for people who like want to contribute and make like a richer ecosystem, and people who want to like innovate on the things that I think make Clojure a clear win.
Yeah, I think the reason why I wonder that though is that like for me the selling point of Clojure is never been like yeah we got that too, right? It's you've been thinking about it all wrong, and look at how Clojure thinks about these problems differently from what you've done before.
Yeah, that's totally fair. But I would actually argue having a machine learning library is not like a you've been doing it all wrong kind of thing. It's more or less just like tables. It's just like pandas. I actually think pandas is really useful. So I think you're right. I think aside like of the three things on this, like your kind of big ML libraries, pandas, and notebooks. Notebooks is actually the thing I'm the most skeptical about. But pandas and like strong ML libraries that are comparable, I think it's hard pressed to say like this is a bad idea or whatever. Like
that's the point I'm making. I think I'm in agreement with that.
Yeah, notebooks are ironically the only thing that we're kind of close on. I actually think is probably not the most important piece of the puzzle. But cool. Anything else? All right. Well, thank you so much, guys.